Hi Bobcats! In this video, we're going to take a look at the basic parameters that are involved in doing calculations with our gas laws. So we'd like to define what those are: pressure, volume, the amount of your gas, and temperature. And then also just quickly review the typical unit conversions that are involved before doing the gas law calculations. The gas laws that we are going to use are relatively simple math formulas that relate these parameters to one another. And when I say simple math, I mean that they're going to involve things like multiplication and division. There aren't going to be the trig functions in there like sine and cosine or any other strange things like logarithms. It's just going to be multiplication and division. The four parameters that are involved are pressure, volume, the amount of the gas, and the temperature. The pressure of a gas is, according to the kinetic molecular theory, is the force that's exerted by the collisions of the gas particles with the walls of the container. In the lab, one of the instruments that's used to measure gas pressure is illustrated over here in this diagram. It's called a barometer. It's a tool that's used to measure pressure. If you go to the gas pumps though, or while you're at the gas pumps, you decide to put air in your tires, you'll see that the unit that's used for pressure is PSI, which stands for pounds per square inch. Pound is a unit of force, and then the square inch is your area, so there's your force per area. In the lab though, we're going to be using different units. There's one unit that goes by two different names, like dollar and buck. It's known as a millimeter of mercury and a torr. So millimeter of mercury comes from a barometer. So when you use a barometer, this tube contains a column of mercury, and the height of that column of mercury in millimeters can be used directly as the measurement of the pressure on the gas that the barometer is measuring. Now, scientists really like to name things after people, so they took this natural unit of how many millimeters this column of mercury is, and they also gave it the name torr, after Evangelista Torricelli, who was an Italian scientist who did work with gases. Very often a more convenient unit for us to use is an atmosphere. 1 atmosphere is roughly the pressure that we experience every day just being exerted by the atmosphere. So the conversion factors that you need to know are right here. We've got that 1 atmosphere is equal to 760 millimeters of mercury, but since a millimeter of mercury is the same thing as a torr, that's also 760 torr. So I expect you to be really familiar with those. And then the 14.7 psi is just to relate that to what you'll see at the gas station. To convert some of our pressure units, let's see, we've got, for this first one, we need to convert 25 torr to millimeters of mercury. So you can start by taking the number that you were given to convert, 25 torr, and placing that over 1. And then we know that there are 760 torr for every 1 atmosphere. So there's our conversion factor. The side that needs to go on the bottom is the side that matches the units of torr. So that means we're going to write torr down here in the bottom, and that has the number 760 in front of it. Then the thing we're looking for is atmospheres, so we will put 1 atmosphere in the top. When I take 25 and divide it by 760, my calculator tells me that's 0.033 atmospheres, because the units of torr canceled out. We can go the other direction as well and convert the 5 atmospheres to torr. So we'll start with the 5 atmospheres over 1, and for every 1 atmosphere, there are 760 torr. So to run that through my calculator, I'm going to take 5 times 760, and my calculator is telling me that's 3,800 torr. And once again, units cancel, atmospheres cancel with atmospheres. According to the kinetic molecular theory, most of the volume of a gas is really just the empty space between those gas particles. So really when we talk about the volume of the gas, it's really the volume of that space between the particles, because the particles themselves are so tiny. So when we go to measure volumes, sometimes we'll need to be able to convert between liters and milliliters. So just remember that there are 1,000 milliliters for every 1 liter. And if we're doing one of these conversions, we usually end up just simply moving the decimal 3 places. So let's practice one of these conversions. We know that 1 liter is equivalent to 1,000 milliliters. The first thing we're asked to convert is 225 milliliters. So we'll start by writing the 225 milliliters. We'll place that over 1. And then we need milliliters in the bottom of the next step. So the number that's associated with that is 1,000. And up in the top, we'll put 1 liter. So we'll have 225 divided by 1,000. Dividing by 1,000 moves the decimal 3 times to the left. So this will be 0.225 liters. Now if we go the other way and we have 3.5 liters that we're trying to convert to milliliters, what we'll need to do is put our conversion factor in the opposite direction. This time we're going to need liters on the bottom and milliliters on the top. So we'll have 1 liter on the bottom and 1,000 milliliters on the top. So if I multiply 3.5 times 1,000, I'll have 3,500 milliliters. If we look at units, liters in the bottom cancel with liters in the top. But back there in that first problem, the milliliters in the top canceled with the milliliters down there in the bottom. The next parameter that we'll deal with gases is how much gas we have. When we use it in the gas laws, we'll need to specify it in terms of moles, but very often in the problems, we'll be given it in terms of mass. And so we need to use 2 of these 3 things off the radiation sign. We'll need to use the molar mass in grams and the quantity 1 mole. The temperature of a gas is one more thing that we'll have to specify in our gas law calculations. The conversion that's most important for you to remember is this one right here, that the temperature in Kelvin is equal to the temperature in degrees Celsius plus 273. When we use the Kelvin temperature scale, we do not write the degree sign, we just use K for its abbreviation. And so remember, Celsius is what we most often use in lab. If you're monitoring your temperature at home, then the unit that we most often use is Fahrenheit. That's the same sort of unit that we also see on the TV weather news. But for lab purposes, that's not what we will use. Instead, we will use Celsius or Kelvin. When you need to convert between Celsius and Kelvin, we need to use that formula from the previous slide, which said that the temperature in Kelvin is equal to the temperature in Celsius plus 273. This is not a dimensional analysis problem. The nature of this conversion is mathematically different. So what we'll need to do is take that temperature in Celsius, which was 25 degrees C, and add 273 to it. That final answer will be 298 Kelvin. Some gas law problems will not give you a number for the temperature and pressure. Instead, they'll simply say this takes place at STP, which stands for standard temperature and pressure. There's the S, standard, there's the T, temperature, and there's the P, pressure. Standard temperature and pressure is simply defined as 0 degrees Celsius and 1 atmosphere. Now, if you're doing gas law problems, we can't use Celsius temperatures, so it's probably best to remember that standard temperature is 273 Kelvin. Pressures we have a little bit of flexibility on, but standard pressure is going to be 1 atmosphere, which is equivalent to 760 millimeters of mercury. Our objectives for this video were to help us get prepared to do calculations with gas laws And so we defined the variables we will see: pressure, volume, amount, and temperature. And we also looked at the basic unit conversions that will be associated with those. Eat 'em up, cats.